Hello again. This is Math 2134 coming to you from the College DuPage, and this is the conclusion of the lecture entitled Product and Quotient Rules for Derivatives. The derivative of the quotient of two differentiable functions is given by the following rule. So the derivative of f of x over g of x is going to be g of x times f prime of x minus f of x times g prime of x all over g of x whole squared, provided that g of x doesn't equal to 0. As an aid to remembering this expression, observe it has the following form. Denominator times derivative of the numerator minus numerator times derivative of the denominator, all divided by the square of the denominator. The proof of this is similar to the proof of the product rule, and I'm not doing it here. Again, note there's an important caveat. The derivative of the quotient is not the quotient of derivatives. Simply put, u over v whole prime is v u prime minus u v prime, all divided by v squared. So there's a problem for you to do. You just find f prime of x if f of x is equal to this quotient. You know what to do. Let's see how you did. So it's going to be denominator times the derivative of the numerator, which is x, minus numerator times the derivative of the denominator, which is 2x minus 4, all divided by the denominator 2x minus 4 whole squared. Now we're going to take the derivative, so that this derivative is 1, and this derivative is just 2. And so this is what we get. We simplify this using algebra. We see that the 2x's will cancel out. And so the answer is negative 4. There's a minus sign here over 2x minus 4 whole squared. Here's another problem for you to take the derivative. Find f prime if f of x is this quotient. You know what to do. Let's see how you did. So this is going to be denominator times derivative of the numerator minus numerator times derivative of the denominator, all divided by the denominator whole squared. Now the derivative of this is 2x. The derivative of this is also 2x. So when I simplify this, the 2x cubes will cancel out, and I'm left with minus. Again, there is a minus sign here in front. 4x all over x squared minus 1 whole squared. Here's another example. We want you to find h prime of x is if h of x is equal to the square root of x over x squared plus 1. You know what to do. Let's see how you did. So it's going to be denominator times derivative of the numerator minus numerator times derivative of the denominator, all divided by the denominator whole squared. So this is going to be, this derivative is going to be 1/2 x to the minus 1/2. This derivative is going to be 2x. And so that's what we have. Now what we're going to do is there is a common factor, and it is 1/2 x to the minus 1/2. So I factor that out, and I am left with this. And when I simplify that, what I'm really doing is moving this to write that as 2 square root of x in the denominator. And I simplify this because x squared minus 4x squared is minus 3x squared. Here's another example. This allows you to practice a little bit with our new derivative e to the x. So you want to compute dy dx if y is equal to f of x is pi x cubed minus e to the minus x. You know what to do. Let's see how you did. Now, first, it is important, at least for now, to write this as a quotient. And later on, you'll have an option to do this as a product rule combined with the chain rule, but not now because we haven't studied the chain rule in this class. So we're rewriting this as a quotient. So this is y equals f of x is equal to pi x cubed is in the numerator, and the e to the x is in the denominator because it was e to the minus x. So then the derivative is going to be, now when you take the derivative of a constant times a function is just the constant gets pulled through. So that is the pi. And now what we're going to do is we're going to take denominator, e to the x, times the derivative of x cubed, which is 3x squared, minus the numerator, which is now just x cubed, times the derivative of the denominator, which is the derivative of e to the x is e to the x, all divided by the denominator whole squared. But e to the x whole squared is e to the 2x. Now what happens now is you have a factor of e to the x in each of these terms, so it cancels in this denominator, and you have an e to the x in the denominator. And when you simplify that and write the e to the x in the denominator this way, you get pi e to the minus x times the quantity 3x squared minus x cubed. Life is a word problem, and we will do word problems in this course. This is a business problem, so you have sales in millions of dollars per year of a recording of a movie 2 years after the date of release is given by this. This is a quotient. So you want to find the rate at which the annual sales are changing at time t, and you want to find out how fast are the annual sales changing at the time it was released, t equals 0, or 2 years from that. You know what to do. Let's see how you did. So we used the quotient rule, and so that's going to be the 5 will just be able to be pulled out in front of everything else. So this is what I'm taking the derivative of the quotient. So it's going to be 5 times the denominator times the derivative of the numerator, minus numerator times derivative of the denominator, all divided by the denominator whole squared. If you do algebra, it can be simplified to be this. Part B. And of course the derivative is the rate of change, but now we're plugging in numbers, so if you put t equal to 0, you get $5 million per year, and if you put in 2, it is minus $600,000 per year is the rate of decrease. Okay, this is a biology example. So you're dumping waste into a pond and doing an oxidation process. Takes place and reduces the oxygen content of the pond, and you care about this if you're a fish. However, given time, nature will restore it to its natural level. Suppose the oxygen content t days after the waste has been dumped into the pond is given by this. Notice that this is a quotient rule, percent of its normal level. So you want to derive a general expression that gives the rate of change of the pond's oxygen level at any time t, and number 2, how fast is it changing at 1 day, 10 days, 20 days? You know what to do. Let's see how you did. So the 100 can be pulled through, and then I take the derivative of the quotient, so it's going to be denominator times derivative of the numerator, minus numerator times the derivative of the denominator, all divided by the denominator whole squared. Notice we're taking the derivative with respect to t. So the derivative of this quadratic is 2t plus 10. The derivative of this quadratic is 2t plus 20. So we've got some simplification to do, but this can be simplified down to this being the answer in simplified form. And now what we're going to be able to do is we're going to be able to plug numbers in here. And so what 1 day, you put a 1 in there and do the calculation, you get approximately this number, and that's 6.8% per day. Here it's neither increasing nor decreasing at 10, so the change is 0. It's changing from positive to negative or negative to positive, and after 20 days you put 20 in and it is 0.37. So it's decreasing at a rate of 0.37% per day. Notice that this is a very small number. This is well less than 1%. In closing, now more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now, more than ever, take care of yourself and of each other. God bless you all.